on this side, a browser peer on that side, they are talking to each other. They are able to produce media, send media, receive media, and show media, right? These four aspects are happening. How is it happening? If you are interested in the gory details of it, this is how it's happening. Peer A is browser side, one browser, peer B is the other browser. How they talk to each other, internally, that as a programmer, that you don't have to deal with, right? These are internals. And you can see that there are a lot of complexity here. There are components like stun and turn servers in between. Those are for firewall traversal and obtaining a public IP, right? Where typically you are operating behind firewalls. So the IP of your own browser as visible outside is different, right? So things like that. How your side of the browser is known to the other side of the browser. What is my IP? How is my IP visible to the other side on a public internet? Similarly, what are my capabilities? Right? I might be running in low bandwidth conditions. I might be running in really efficient bandwidth conditions. I might be working on a smart device, or I might be working on a full-fledged desktop, right? So based on these conditions, what are the kinds of media? Can I send high fidelity video, right? Or should I send just lo-fi audio? So the type of media exchange, what kind of media encodings that should be used, those things will also happen. Those things are captured under something called SDP, Session Description Protocol, which is where the media type is described. Hey, I want to talk to you with both audio and video channels. My audio will be encoded as, say, Opus, right? And I'm going to send my encoded audio in so-and-so bandwidth or frame rate. So all of this information, my capabilities, how I can transmit media data, that is encoded in something called SDP. So before I can talk to you, I have to tell you what my capabilities are. Then if you match up with those capabilities, for example, I want to talk hi-fi video, VP8 video. You cannot talk VP8 video, you can only talk, say, H264 video. We both have to agree upon the codec, right? This is called media negotiation. So, media negotiation, how the media is packaged, how the media characteristics are informed to the other side, and what the other side's characteristics are, how these two guys negotiate with each other, what kind of agreement they reach upon, and ultimately the media communication starts happening with an agreed codec, with an agreed frame rate between these two endpoints, right? So that idea is being captured in the sequence diagram here. This is public. This is available from Mozilla.org. Again, this is plain vanilla WebRTC, right? We are talking about a browser situation. So let's talk about real-world WebRTC. In real-world WebRTC, well, if you think about it, plain vanilla WebRTC, there is no way to figure out who the other side is, right? When I'm making a call with my phone, I know who my other side is. I know the phone number that I should be dialing. I always know my other side, right? But in case of browser and browser, how do I know who the other side is? What is the identity of the other side? Given I know the identity, for example, I want to talk to Raj at app.com, right? If I want to talk, how can I figure out, how can I reach Raj at app.com, right? So there are certain gaps intentionally left over from the WebRTC standards. These gaps, they're collectively called as signaling channel. It is happening for a reason because the WebRTC standard authors thought that the signaling channel, how browsers should identify themselves, how browsers should communicate with themselves. I want to make a call. I want to start talking to you. Okay, I'm ready to listen to you. Right? These kind of messages. This is called signaling. Right? So this signaling piece is left left without any standards intentionally by the W3C and IETF bodies, standard bodies. That's because anybody, any organization with communication capabilities, they should be able to define their own signaling channel, and which is what AT&T did. We did fill up the signaling part of it, right? I'll show you how. Remember, one of the challenges in signaling part is, how do I identify myself, number one. How should I identify the remote party, number two. How should I reach the remote party, number three, right? These identification issues, reaching issues. This is where AT&T has provided this WebRTC API platform, where existing AT&T subscribers can be automatically identified. Right? If you're an AT&T subscriber, you already have a WebRTC ID with AT&T. Right? The other option is, if you are not an AT&T subscriber, which is not good for us, you can also rent virtual numbers from AT&T. Right? Yeah, you can be our competitive, competition carriers subscribers. But if you want to use WebRTC, you can rent virtual numbers from AT&T. Not only that, you can also use account ID from AT&T. Account ID is, just like your email ID, right? Raj@myapp.com. That becomes a full-fledged identifier to make and receive WebRTC calls. This is another interesting thing. So far, we needed to have numbers to make and receive calls, right? Now, with account ID facility, which we are going to actually do hands-on in this labs today, the account ID facility will let the browser as account ID be able to make calls and receive calls. In other words, your email ID kind of thing, it has become a full-fledged WebRTC endpoint. Right? Imagine you have a Twitter ID, right? I think I was discussing this with one of my colleagues before. You have a Twitter ID. With Twitter today, you can only do 140 character messages. Or I think they increased the limit for direct messaging these days. But with the same Twitter ID, if you wrote a WebRTC based app, this way Twitter ID can also be used to make and receive audio video calls. As simple as that. Right? Account ID is such a powerful feature. We will understand more about it by doing enhanced. And of course, in enhanced WebRTC, AT&T's flavor of WebRTC, as I told you, it's a signaling choice. These choices will give you existing AT&T subscriber identities, or you can rent virtual numbers and use them as identities, or your username at yourdomain.com can also be used as an identity. So a fully integrated identity solution. So that is identity. Then calling. Of course, from browser to browser, you can do audio, video calls. Of course, the usual telephony functions, like the functions available in your dialer, right? Make call, receive call, hold call, resume call, mute, unmute, add call, then conference folks, right? You can do all of that using WebRTC. And you can do all of that by using JavaScript methods. That is the point I wanted to stress here, right? Now, I don't know who wrote the dialer on iPhone, but you can write a dialer yourself and put that into your web application. Enrich your existing web application using real-time audio. You can do that just by using JavaScript. I'll show you how. And some special features I talked about conference. Conference is somebody can start the conference, invite the participants can join, and in a conference, You can hear the audio of all of the participants, or video of the active participants, something like that. Interesting things with advanced calling features in AT&T offering is move, transfer, and switch. Switch is a bit intuitive. I have a call ongoing, then a second call comes in. You can switch between the call in waiting or the call ongoing, right? That is switch call. You can put any of the calls in the foreground, any of the calls in the background. You can always have one call in the foreground only. Transfer is your receptionist scenario, right? You don't know the actual number of the recipient, of the target that you want to talk to. You want to talk to Mike, you know that Mike works for AT&T, but you don't know what Mike's real number is. So you are calling the receptionist of AT&T, and receptionist knows how to forward, transfer your call to Mike. Right? Again, of course, we are familiar with this kind of usage model as well. But again, you can write such transfer functionality, PBX kind of functionality, just by using JavaScript. The entire PBX system can be written using JavaScript. So that is transfer functionality. Move is a special feature, at least from AT&T perspective, and because it is available only to AT&T subscribers. Right? So what Move is, if you are an AT&T subscriber, you can use AT&T. I told you, you are already an AT&T Web RTC user, right? So what happens is, if I actually call you, you are an AT&T subscriber, you agreed to use an AT&T Web RTC app. Now, I am calling you. You will get rings on your device as well as the browser. We call that as simultaneously. So up to you, based on your convenience, where you want to pick up your call. I will demo that to you. Kevin was talking about the demo with the plan product integration. As part of it, I'll show you how to do it. Right? So we call that as simultaneously. What happens is, let us say, you chose to pick up your call on the browser. You can move the call from browser to the device seamlessly. You need not break the connection. You just have to initiate a new type of signaling. The other side does not even know. Other side feels a temporary code, right? But from browser, you can invoke a move function, and the call will continue onto your device. So we call this as move function. Move, again, once again, is exclusive to AT&T subscribers. Sorry. So those are the calling features. But of course, where do you want to integrate? What are the application possibilities to integrate real-time audio-video communication? Umpteen possibilities, right? Think about it. Customer service, right? Let us say I call my bank. I figure something bad in my account. To describe that to my service representative is really, really hard, particularly if it involves real technical problem, right? So you can simply share the screen and show exactly the problem that show in real time to the customer service representative exactly what is happening, exactly what your concern is. My balance is supposed to be $1 million, it's only $10 now. You can actually show the screen by sharing to the customer service representative, right? Behind the scenes, this is what is happening. Well, I don't want to dwell too much on it. AT&T's enhanced version of Web RTC has a lot many more components working behind. I told you that AT&T subscriber is getting additional benefits. We do have virtual numbers, we do have account IDs, and then you are able to make calls from browsers to any US domestic number, any number. Similarly, you can receive calls from any US domestic number to your AT&T subscriber number or virtual number. Yes.
So is that only using AT&T, or can that be utilized by Sprint or by Verizon, or is it just the AT&T?
I can actually call any number, Sprint number or Verizon number or whatever. I can make calls. I can call out to Sprint or Verizon.
Okay.
Similarly, I can get calls in from Sprint or Verizon so long as I am AT&T subscriber or virtual number.
Okay.
Account ID, it's a kind of alphanumeric string, right? So the competitors, they cannot forward those calls to us. So that.
Now, is there any additional cost to doing that, or is it all across the board?
The plans are no different.
Okay.
Actually, the way that you get billed using the device is the exact same way you get billed using the browser as well. Calls from functional perspective are no different at all. Okay. So I just wanted to bring this up just to tell you the enhanced part of it. AT&T built a new platform called IMS Innovation Platform just to enable Web RTC on the existing PSTN, LTE, and 4G network that they already have. Okay. Now, so this is all behind the scenes. I just described to you what Web RTC is, what is AT&T's flavor of Web RTC, what do you mean by enhanced portion is, right? Now, let's say I've been teasing you about these things that can be done just using the basic JavaScript. How is that possible? That is possible because our team, actually I lead the team that wrote the JavaScript framework to use the AT&T API. What we did was, we created an object called phone, a JavaScript object. When you include this library, when you include jQuery, you get dollar, right? If you are familiar with jQuery framework, you get the dollar alias, and using the dollar, you can do anything. Basically, you will invoke methods, you will register event callbacks using dollar and jQuery object. Similarly, using phone object, you will be able to make call. Phone has methods like make call, receive call, end call, hold call, just like your typical dialer. All the dialer functions are tagged down to the phone object using really intuitive method names. All you have to do is just write JavaScript code to use those methods. That's it. Right? So this is what it does. Correct. For developer. That is kind of a developer revenue sharing model, right? You want to provide audio video mechanism to your customer. Basically, you are taking that responsibility. You are getting the product. Okay. So what is happening here is the phone object. It is kind of insulating a lot of complexity. Remember the big sequence diagram I showed you earlier. What is happening? How I'm identifying myself, how I am producing media, how I am telling about my characteristics to the other party, how other party is negotiating with me, how we agreed upon it, how we arrived at the agreement, how we started. There is a dance between these two browsers that has to happen in a really predictable manner, right? Step one only after step 0, step 2 only after step 1, something like that. So this is really complex. Trying to do this programming right from ground up, complex. So we simplified, we took the complex step on ourselves, we wrote the library, and we are exposing this single phone object, which developers like you can use very easily. All right. Let's say something in action, right? So, any questions? We understood about Web RTC, right? At least I talked about basic Web RTC. I don't know if you understood or not. Any questions? Please let me know right now. Then I talked about AT&T's flavor of WebRTC, what AT&T is trying to complement in the vanilla version of WebRTC. By this complementing, what are we getting? The identifiers, etc., etc. And then different types of end users. AT&T subscribers will get automatically the WebRTC customers. You can rent virtual numbers. You can do account IDs. We talked about that. Then we said that for developers, we are trying to make programming real easy. To that effect, we created the phone object. And using the phone object, it should be really, really easy when you are trying to write web applications using HTML5 and JavaScript. Right? That is the essence of it. But let's see this next. What I have is a simple web application. Actually, a web application that you are going to actually do in this develop itself. I'm going to show you the final state of the application. Okay? Really dirty, quick HTML5 app. Just some buttons, some text fields, some video, and something like that. Okay, I'm just starting. I have already deployed that HTML. I've started the server. I have used Node.js.
Is it possible to change your color scheme? That's sort of hard to read.
Oh, okay, sorry. Got it? Okay. So, I'm going to, I have started the web application. I have already deployed this web application. I am going to visit my web application. This is where I am running it. My application is att.html. It is a simple HTML JavaScript file. All right. This is just an error dialog because this HTTPS I am using a dummy certificate. So it is showing me this error. I accept it. I'm going here. Right? You can see the first page of this. Very, very simple. Remember I talked about any user at myapp.com, right? It can become a WebRTC user. We call that as account ID. So let me pick up an account ID, an arbitrary account ID. Let's say tester1. And this is my account ID domain, sample.irtc.net. It can be any domain that you choose. In fact, we are going to do that as part of our labs. In my case, I chose sample.irtc.net. It's totally arbitrary, right? So when I click login, what is going to happen is tester1 at sample.irtc.net. Can people in back rows can see it? Should I? Okay, so this is the problem with, well, I guess. Okay, so what I did was, I entered some arbitrary user ID, right? Tester1 at sample.irtc. This is where I am running my app, and this is my user. I just logged him in. So because I logged him in, he is able to make and receive calls, right? Okay, let's try the make call. Who wants to give me a phone number?
44,
You have to shout really high.
44,
144
454,
454
5673,
5673.
73.
Okay.
Private, but I got it. I
Alright.
can call, but it's private, so.
Yeah, you got it?
Yeah.
Okay. Yeah, actually, can you say something?
Answer.
Hello?
Say hello.
Hello?
Did you mute it?
Call it again.
Hello?
Call it again.
Oh, okay. Call again. Right. Did you already? Oh, okay. You already disconnected. See, that it disconnected. That event is actually coming to me, right? And I'm automatically capturing it and showing it. He's a hang-up guy. Hello?
Hello?
Okay, now you're hanging up. You're not hanging up.
You're not hanging up.
Fantastic. All right. So this is a real, you can see how dirty this UI is. Very simple UI. All I did was use the phone object to capture our friend's phone number here and use phone's method to make it call. That's it. Right? So, let me just, sorry. So, does it make sense? So, can you see the implications of this? This is my dirty JavaScript, HTML file JavaScript. Let us say you already have working full-fledged JavaScript application like a Bank of America or wherever, right? Integrating this real-time calling a customer service representative, receiving a call from customer service representative after you log in. Let us say you already logged into Bank of America website, right? Now you receive a call from the website itself. Now, you don't have to go through all this routine of, my last 4 digits of my social security and then 5 digits of my zip code and, my wife's, mother's, father's last name. What, you don't have to identify yourself. You already have identified yourself by logging in and be able to receive calls, right? You already have identified, established identity. So, think about, these implications. What I am showing here is, just be able to make and receive calls. I showed you that it is very easy to do so. But the things behind it, the identifier, establishing a session, right? And be able to make and receive calls, integrate this real-time audio-video experience into your existing feature. That is what we want our developers to think about and come back to us with ideas as well. Now, let me end this and let's, already discussed. Okay. Okay. Yes. Good question. The question is, okay, when we talked about audio and video today, I demoed the audio call. During your labs, you will also see video call. Right? Question is, are you providing additional video functionalities like screen sharing? We are not building it in, but we are kind of providing a proof of concept kind of thing. How you can share screen from the browser, how you can share screen from your desktop, and send it via established communication channel. That is not part of the core product. Ultimately, once you start sharing screen, it is really great, right? The challenge is, how do you capture video from sharing the screen? That is the whole challenge. Once you get the video, sending it via the pipe, you can use the same pipe. We are going to do that pretty soon. Right now, we are focusing only on audio and video. But screen sharing and data channel, some of these things are the best.
How is this different from the Google Hangout, Google Voice platform? I mean, I get that it's, open source, so that's
Right,
one
right.
big difference.